8.2, solving absolute value equations. Yesterday, or a couple days ago, last section, we talked about how to graph these things, how to graph these absolute value functions. And we know that they look like V's if they're linear, and they look like W's if they're quadratic. Basically, anything that goes below that x-axis gets bumped up or flipped up. So any negative values of y turn into positive values of y. What happens when we're solving absolute value equations? What's happening graphically is seeing where two different functions match up, or where two different functions intersect. But when we do it algebraically, there are a certain kind of like set of steps that we need to do to be able to solve them algebraically. But solving them algebraically, solving them graphically, we're getting the exact same answer. We're still solving. They're just two different tools to be able to do the exact same thing. So now, today, we're going to focus on algebraic skills. So if I would say that the absolute value of x is 1, there are two different answers for x, right? X can be two things. X can equal positive 1, awesome, but x can also equal negative 1. Let's think that through. Why can it equal negative 1? Because the absolute value of negative 1 is 1. So we have two different solutions. This is the crux of what we're doing. If you can understand that there are two different solutions for every absolute value, then we're good. Okay? So if you understand this, you're off to the races. Say we had something like x minus 1 equals 2. What we want to do is we want to split this off into two separate questions. I know. Okay, where negative x minus 1 equals 2 and positive x minus 1 equals 2. Okay, the same thing that we're doing here, x equals positive 1, x equals negative 1, we're doing the exact same thing here. This is like our negative 1, okay? We're taking one negative side and one positive side.